Are you ready for some time traveling? So from Jetro's presentation on Porrasturvat 20 years ago, now we fast forward to the current moment where Jani will continue the story of Dismount.
Absolutely.
Please, Jani.
Thank you. Hello, everyone. So this is a talk with a cryptic name, the art pipe of Dismount. We obviously have not announced Turbo Dismount 2 yet, and we denied developing it, so hence, keep the secret. So, art pipe. We're a small indie studio, roughly between 5 and 8 people, depending on how you do your math. Yet Turbo Dismount itself had quite a success in its days. Altogether, I think the Dismount games have been downloaded about 100 million times already. So for a team of 5 to 8, that's quite a large audience to keep happy. And with Turbo Dismount, we learned it the hard way, that if you haven't done a smooth and productive pipeline for art development, then creating constant new content will keep you busy far more than you were hoping to. These were the central themes when we were thinking how to do things better. And this is the presentation about the conclusions that we've come to. So what's important to us? We have basically 3 pillars that define our current method of content production. The first is palettes and colors instead of detail. The second thing is the power of subdivision surfaces. And the third one is that we should leave the monkey work to the computers. So automate what you can, even in case of artist tools. But going to color palettes. So the expressiveness and the emotions of just choosing the right color palettes can create really, really memorable environments. It's not about normal maps and high detail textures. It's really about the contrasts, the tones that set the emotion of the scene. So these examples are, of course, from comic books, well-known comic books as well. And you can see that palettes instead of detail has been applied successfully in a number of video games as well, from Monolith Valley to Mirror's Edge, Journey, Another World, Inside, Firewatch, and even in many games in the 16-bit era and 8-bit era, they relied on palettes entirely. But what about the real world, you say? Well, palettes have successfully been applied even in movies, as exemplified by Wes Anderson, for example. And when we look at palettes altogether, then we've reached a point in computer graphics where tools where palettes are available have become quite abundant. So this is something that we're keeping well in mind. And then to the second pillar, OpenSubdivs. And these are my personal favorites. I'll come to the more details later, but the idea in subdivision is, of course, that the artist is responsible for developing and creating only the essential detail that describes the object. And subdivision itself just then smooths it out, brings out the physicality of it. We see often in AAA studios that subdivision is sort of reserved for just adding the final touch, like subdividing tens of thousands of polygons into hundreds of thousands, and so forth. But what if you start from really the ground up, that you think of a 100 poly shape and use subdivision to bring that up to the poly count of a modern visual? So for example, just some game assets, and nobody can argue that these wouldn't be considered low poly. But then when you subdivide them, they're starting to resemble sort of claymation style perhaps, very toy-like visuals, which are in line with what we're going after. So in case of characters, I would argue that the wireframe that you're seeing on the left is a fairly low poly face model. And the thicker edge lines that you see, they are creases. So crease in a subdivision surface defines how sharp that particular edge line is. And you can use those for your low poly model as an artist to be sort of a director for the computer. You annotate your mesh with additional information of sharpness and so forth to bring out the final shape of it. Also, in case of animation, with subdivision surface, if you're animating only the vertices on the control cage and you leave the subdivision surface to do the work with its creases, then if you look at the mouth region of this character, the sharp lines near the edges of the mouth and so forth, these are things that you essentially get for free. And also the animatability of that mesh when all the points, all the vertices on the mesh are essential detail, not already subdivide shapes. Then whatever vertex you click and drag to bring out an emotion, an expression, it's very simple and straightforward to do this. And so bringing back here the idea of Wes Anderson palettes and your subdivision surfaces, here is the toy-like asset paletted in different styles of Wes Anderson movies. So paletting is a quick and easy way to bring a lot of variance to even a small set of assets. The one thing I'd like to point out is that we are not using vertex colors in the typical way of having a flat shaded low poly mesh, but we apply vertex coloring even to material properties. So what we're doing is subdivision shapes that are shaded with a physically based model where even the smoothness and occlusion and such material properties are included in the vertex data. These are not baked light maps or anything like that. So for example here, the same character split into the different vertex layers of where color is located and how material properties are split. And we store the material properties in the UV channels of the mesh. I mean, certainly nobody can argue that the character itself is not AAA realistic. But then again, depending on the art style you're going after, this at least is something that we would be very, very happy with, technically at least. In case of a hypothetical game not currently in development and that we deny developing entirely, such assets may appear or might appear like this. So what I'm talking about is that the way we do our assets, at least I feel that we are directly opposite of the popular and widely taught sculpting pipeline. So when you start with 3D sculpting, you give the artist just basically an unlimited amount of polygons, and they work in ZBrush or other sculpting software, creating just out of clay. And the poly counts are in the millions. And then this huge point cloud of data is then baked and crunched down into tens of thousands of polygons with a normal map that brings out the detail. And even this thousands of polygons of mesh then needs to be further abstracted by some sort of influencing, skinning, and so forth to make it something that you can work with. The base mesh itself, it's not straightforward to animate, like the vertices of the face that I just described. You need some kind of brushing tools to abstract the point cloud. So the sculpting pipeline starts with something and tries to cram that down into something that you manage, whereas I feel that our pipeline starts with something small and adds the detail downstream. So combining these elements of palettes and the color variants that you can do, taking low poly objects and then subdividing them into something that you use it in a game. Let me just show how those would work out in real time. So here is a hypothetical game not currently in development. And whereas Turbo Dismount 1 was built with Unity 4 and the visuals afforded by it, now that we are working with a newer version of Unity, using the universal render pipeline and rendering these subdivided meshes with a physical-based rendering, I feel we're getting fairly good visuals. And as far as palettes go, then let's see. Silky pink, purring purple, gamma ray cherry apple. And we have not implemented greater control beyond this right now in a hypothetical game. But assume that what if you had controls like this, which you could apply in real time to the entire world? I'm saying that we are not doing that, but essentially this kind of palette control could be applied to all the assets currently visible, because they have passed through the exact same authoring, processing, and export pipeline. So in a game like, like Firewatch, like Inside, Journey, and so forth, these sort of mood changes that you can apply, not just by post-processing and tone mapping, but by actual palette control, they are an interesting thing that we would love to visit in the future. So how does this look for the artist? So this is Blender, and here on this line, this is probably going to be tough to see in the stream. But what we have done in Blender is a custom add-on which makes vertex colors into a layer-like thing that you can work on. So you have your mesh, and here is your layer list. From layer, we have 7 layer colors, then gradients that are blended on top of those, and the different material properties. You can view those in a composite view, or in debug mode, just layer by layer. The end result of what an artist authors for our game is, as you can see here, a very, very low poly object, even half of one. And as I said, we're hoping for a computer to take care of the monkey work. The artist has created this low poly model. The blue edges are, again, the crease lines. The creasing strengths are set in our tool over here. You can also do similar kind of selections for bevel edges. And once your object is sufficiently authored, our tool offers a magic button right here. And you essentially click that, wait for a couple of seconds, and let the computer do its work. And there you go. So this is what you get when you annotate the work and leave it for the computer. Our assets in the game are currently roughly in hundreds of objects, and each one of them authored in a similar way. And we feel that it's efficient and even rewarding for an artist to do it like this. I mean, as opposed to working on a sculpting tool where you don't care about the topology so much, this work is sort of the old school 3D modeling approach where every vertex counts. And when you place your vertices and your edge loops just right, so that it works with subdivision, the end result is beautiful and smooth physically appearing objects. The tool that I showed, the Blender add-on, it's MIT licensed, available on GitHub, but free for anyone to grab and try. It's mostly maintained by me, so if there's any problems with it, just send me an email or ping me on Twitter, should you feel interested in trying it out. So that's the part of the pipeline involved with art tools as such. The second part is stuff involving professionalism. And this is a moment of sort of a personal humility and humiliation, but believing that you're experienced and professional, and then sort of thinking that it means that you do things well, it doesn't always go hand in hand. So being a professional is more about doing than being, and as long as you remember to do things right, then they end up right. But if you wing it, then things might fall apart at some point. This is something that happened in our project, hypothetical project that we deny. We had our source assets in Dropbox. And they did have a clearly laid out hierarchy where everything should be. And we knew that, okay, these blend files are in this folder, these blend files are here. Then suddenly we found that some of our blend files were in final folder or temp folder or artist name / temp. And these files here were used to export objects into the project folder. So not only did we have FBX files inside our project, which we did not actually know. I mean, they were exported from the wrong place, but even worse than that, the exported objects had different names than the files themselves. So we couldn't tell exactly which game object or mesh in Unity had come from which blend file. And this was a problem. And it wasn't related to version control, it was really related to controlling your assets. So we needed to find some solution for that. And the idea is implemented in this other tool called SX Batcher. So SX Batcher is a parallel and distributed batch processor and exporter, it's written in Python, so it runs in Windows, Mac, and Linux. And it basically updates a JSON file, which knows which file relates to which mesh object in the Unity project folder. And before we had this information, the FBX files themselves were kind of the crown jewels. You had to make sure that they were there, because otherwise your game might break, but you didn't know where they came from. But now, when we have a batch processor where you can basically press a magic button and it just dumps your entire asset database or exports it into your project in a matter of minutes, then the role of FBX files in a Unity project comes very less critical. I mean, your full assets are something you can regenerate in a matter of minutes. And this was a good idea for us. Also, the tool itself updates a revision index per each asset, so no additional work is needed if an object hasn't been changed. Just as a quick example, here's how it looks. Very, very retro Windows 95 aesthetic. So our assets are contained in a JSON file. They are divided into different categories: buildings, vehicles. You can pick which objects you want. You're shown which keyword tags they contain. And you can search your catalog for keywords, or you can pick objects by category. You can just choose to export all your vehicles and then press Start Batch. The good thing about this is that if you selected all your objects in Blender and pressed Export, this would not be a multi-threaded or multi-processing operation. So it would be a long, long batch file to open each file, process it, and export it. But SX Batcher spawns as many blenders in parallel as you have CPU cores in your computer, which greatly reduces the time it takes to go through all of these objects. We even went one step further. It's not just parallel, it's distributed. So every computer in your office that has this tool running, it can just choose to share its CPU cores. They're both kind of main and node to each other. And so this further reduces the time to process all of your assets. Now, once we had spent like 2 weeks in getting this networking stuff actually finally working, one of our engineers noted that, hey, look, why don't you just process the objects that were changed instead of everything, which was very, very rewarding. It reduced the amount of work to like 1% and made all of this pretty redundant. But we're proud. We've done it. It works. I mean, whenever you need to just re-export your entire assets, you can do it really, really fast. And this is, again, in GitHub, free to use. Right now, it's a very Blender-specific thing. But the hope here is that with wider adoptance and hopefully some contributions, this might be extended to cover other assets as well. I mean, it's already, the basics have been implemented to make it agnostic as far as what kind of assets it's processing. But the idea that your entire game assets, including, for example, Photoshop files and such, which may need batch processing, if this could be implemented here as well, then it's an interesting prospect. Something for the future, at least. And that's pretty much our art-to-engine pipeline. So we use Blender. We use SX tools in Blender to create these vertex-colored objects. We use SX Batcher to maintain the assets inside Unity. Thank you, everyone.
Thanks, Jani. Thanks so much. Now it's time for questions. If someone has a question, please raise your hand and I will bring the microphone. Sounds like no questions, so yeah, thanks again.
Thank you.